this, be careful. Sine times sine is, do you remember that sine of x squared is funny? I'm going to write sine of x and I'm going to write squared on the outside. I'll tell you about what it's equivalent to here in a minute. And then do sine times cosine. So it's just sine times cosine. Okay, nothing fancy. And you all had trig, so you've seen this before. And then I'm at the cosine, I distribute it and get negative cosine of x sine of x. And there's a shortcut to this, and I will point it out. And minus cosine squared. Now I'm putting cosine of x in parentheses and squaring it. I'm going to write it in a different form here in a minute, and it's important to know both. All right, you all see in the middle here, just like I do, that these two, whoops, bad color choice. Try again. Even this is a little rough, but those two cancel because there's a positive and a negative. They're like terms, sine and cosine and sine, the same idea. Just remember those are the same, they can be canceled, and that's good. Then what you're left with is sine squared. Now I'm writing it differently, but I want you to know that these are the same. When you put a little 2 above sine and the x doesn't have a squared next to it, it means the sine, the whole thing in parentheses, is squared. So you want to recognize that these two are exactly the same. It's good to know because sometimes you think it's like the x that's squared, and it's not the x that's squared, it's the sine, the whole thing is getting squared. And then minus cosine squared x means the same as the whole cosine shebang squared. The x does not get squared, it's just the function itself. That's it. Sine minus cosine looks great. Sine squared minus cosine squared. You might think there is do you remember sine squared and cosine squared and it having like some value? Most people kind of remember it. Do you remember it being something? Do you remember sine squared plus cosine squared is 1? That's called the big Pythagorean identity. This is not that. It's a little different. This is sine squared minus cosine squared. Interestingly enough, there's an identity that goes with it as well, but we'll get to it later. For now, all I want you to show you is that this makes sine squared minus cosine squared. That's the long way. What I want to show you is what I need you to start recognizing, though, is one of 3 really, really big ideas in this section. And they are, you need to recognize the difference of squares when you see it. It's really important. This is like a minus b times a plus b. And if you remember, a minus b times a plus b is always equal to, yes, your a squared plus b squared. It's called the difference of squares. It's one of our favorites. Difference of squares. And the word difference because you're, now, I wrote the, oh, poop. You guys, I said difference of squares. Good thing I was reading my own words. A squared minus b squared. Silly. And the word difference, right there, is in reference to the fact that you're doing a difference of 2 perfect squares. So you have to know difference of squares 2 ways. You have to know a squared minus b squared is equivalent to a minus b times a plus b. But you also have to recognize when you see something minus another, and then the other parenthesis has the sum of the 2, the product is always the first term squared minus the second term squared. It's a recognition tool that becomes really handy. So this problem was actually there to remind you that if you ever see this again, you go, oh, it's difference of squares. I could just go sine squared, the first one. And order does matter on this, by the way. The first term squared minus the second term squared. Cosine squared. We did it the long way first, but the shortcut, that's your goal. You want to know that one. Difference of squares. On to the bottom, and then we can start playing with some others. So it says factor. When we rewrite stuff, sometimes it's nice to write it in factored form. So if they have a common factor that you can divide out, you should go for it. And I'm going to divide out, in this one, they both have a sine of x that I can divide out of them. Factoring is literally dividing out of this. Notice how I pronounce that. That was for your benefit. Normal pronunciation. I'm dividing sine of x out of there. Okay? So when I divide it out of the first term, what I get from dividing these both by sine of x, that's what goes in the parenthesis here. So the first one, if I take sine squared divided by sine, it leaves behind sine. And when I take sine of x over sine of x, that's just uno. Done. That's factored. if you want to know when that's going to be helpful, do you know that we solve equations later on? And factored form of, like, if this were set equal to 0, way easier than if it's in regular form. So when that comes, this doesn't say solve, but it does say factor. The benefit is when we do start solving, you'll like that you can factor those. It'll be helpful. Okay, on to the next. Can you factor this one? That's a little weird. This one is a little less eye-catching, but can you see that it's like a squared, ax squared plus bx plus c? It's like Pythagorean-like, or not quadratic formula-like. Man, my words are all off. My quadratic formula looking. If you can see it, you're a superhero and you have amazing powers. If not, I'm going to help you see it, if at all possible. If I change this out to be like u replaces sine of x, it looks like this. This is a temporary replacement, by the way. It's just me saying, all right, this means that would be u squared minus 4u minus 32. If I do that, then you look at it and go, oh, okay, yeah, I can see that. I can see it's something squared minus something u minus 32. I know how to do the quadratic formula for that. Or do the factors work? Like, do any factors of negative 32 add to 4? We got 8 and 4. I think we can do it.
Where did the u come from?
It's a temporary deal. So, Carter.
Do we need to like know that?
Well, do you know why did I put that u in there? What was the deal? It's a visual aid. So is it required? Absolutely not. But what it is,
So sine is u.
if this is a temporary, this is actually a practice that we use a lot later on, but this was just so I could better identify that this was like in the form of something I could use quadratic formula. So I could see more clearly. So it's like putting on a special glasses. My sine of x that was kind of confusing, I magically turned it into a u and looked at it and went, oh, that kind of looks quadratic. Now, it's not, I didn't change it from being sine of x. I'm going to put it back as sine of x. But it was for you to kind of look at it and say, oh, yeah, I can see the form now. Makes sense. Maybe it doesn't, but hopefully it's clearer anyway. Now I'm going to put purple back on here. So it's a visual aid. If I factor it with the u's in it, that's fine. As long as when I'm done, if I put sine of x back in where the u's are, it's all good. I just did it temporarily. It's actually a really important mathematical technique where you replace something with something simpler, do all the math, and just put the sine of x back when you're done. Okay, so it's okay. So what were the factors that worked? Negative 32, was it minus 8 plus 4? So if I do u minus 8, u plus 4, in this very familiar form, it's factored, right? But we know u is a temporary thing. I just did it to make my life maybe easier. Maybe it made it more complicated. I don't know. You can make that call. But it is a technique that we use. We substitute u sometimes to help us see a pattern better. And now, some of you, rock stars, that's a lot of you, by the way, you could probably just say, oh, I get it. It's something squared x minus 4 times something minus 32. I could have just done sine of x minus 8, sine of x plus 4 right away. Why would I do the u thing? Well, that's fine. You don't. But I need you to recognize that quadratic form of these trig functions because you're going to have to factor them.
So why u?
If you would prefer, u is just a temporary deal. I could have picked any symbol, letter,
So then why does it
shape.
u?
I like it.
I'm just kidding. I don't get it.
Would you? I draw a pretty nice picture of a frog.
What? You're drawing a frog?
Yeah, we should use little pictures of a frog instead of you. So my frog isn't so good, but I could have used a frog.
It just looks like
Mr. C, that's a wonderful
a
frog.
piece of like
thanks,
iceberg.
but-
grease.
No, the frog is over. My frog.
You need a
my
red
frog.
tongue. You need the tongue.
Sure. Thanks, Nathan. It's okay.
Use a frog in the next picture.
Maybe we'll use a frog on the next one. But it's a symbol. It's a representative symbol. I could have used a square or a circle or something that just helps me pick up on the pattern. The fact that you're asking means you kind of get it. So thank you. That's good. Tangent squared minus 9. It's difference of squares. We saw it a little before. And if you can't see it, it's one of those that you need to start training your eyes. So you guys remember I was talking about you can train your eyes to pick up on details. And actually, you guys as a high-level mathematics class already have really good filters for picking up on patterns that most people freak out when they see stuff. The fact that you don't freak out all the time about the things that you see on the page, because we look at some pretty crazy looking stuff, means that you have a really nice filter. You guys recognize complex mathematical things as having some sense to them. That is one of the wonderful ways that you guys are kind of on the top tier of capability in the world, is that you look at complex stuff and you're not afraid of it. You're like, there's a pattern, there's a reason for that. It means something, and you don't panic. And that is one of the many reasons you take a math class, is that you're getting familiar with complexity and numerical representations and symbols, and you're like, I want to find the meaning of it. I don't want to panic and run to my room and hide under my covers. And then you know what happens? Because of your lack of fear, somebody pays you money, much, much more money than they pay me. And it's great. You should enjoy that. So enjoy that you're really at the upper tier. You're doing well. Life is good. Doing well. Does that help? If I say that's like an a squared minus a b squared, that's a plus b times a minus b. So tangent is my first thing, and b, or 9, do you recognize we have to be careful what our a is? Our a is going to be tangent, and our b is going to be 3. And I'm actually going to write that off to the side here. For us, a would be tangent. You don't have to write it if you don't want to. B would be 3 for this little thing that I wrote up here. So tangent of x minus 3, tangent of x plus 3. Does it matter that tangent goes first? It does. It really does, actually. Whatever one shows up first in your difference of squares, it also needs to be first in your parenthetical products. Okay. We're on a roll. We're on a roll. I hope you're enjoying it. It's just rewriting it in different forms because I promise it will make life better later.